Hello students, welcome back to our channel. Hope all of you are doing well as usual. Today we will solve this problem on trigonometric limits. But before we start the problem, let's revise the formulas of certain trigonometric limits. We have these formulas: limit of sin x upon x when x tends to 0 is equal to 1, limit of tan x upon x when x tends to 0 is equal to 1. Same way, limit sin kx upon x when x tends to 0 is equal to k. Similarly, we have one more formula for the trigonometric limit, that is limit of tan kx upon x when x tends to 0, that is also equal to k. Now let's see how to use these formulas here. Now in this problem, we want to find the limit of this function when x approaches to 0. Let L be the limit of this function. So I will write L is equal to limit x tends to 0 x tan x upon 1 minus cos x. Now we know the formula for 1 minus cos x, that is 2 sin square x by 2. Let's substitute this value here. Hence we will get L is equal to limit x tends to 0 x tan x upon 2 sin square x by 2. Now this 2 is constant, so I will take this 2 which is in the denominator as a common outside the limit. So this is 1 by 2 limit x tends to 0 x tan x divided by sin square x by 2. Now what we will do, we will divide numerator by x square and also denominator by L square. So 1 by 2 limit x tends to 0 x tan x so I will divide numerator by x square and also denominator by x square. So I will simplify this. Half limit x tends to 0, this will be tan x, numerator will be tan x upon x divided by sin x by 2 upon x the whole square. Now let us take the limit of this numerator function separately and also the function in the denominator separately. So we'll get now limit x tends to 0 tan x upon x, while in the denominator limit x tends to 0 sin half x upon x the whole square. So this is half. Now what is the limit of the function in the numerator? That is limit tan x upon x, x tends to 0, that is 1. So I will substitute this limit divided by, now this is limit x tends to 0 sin half x upon x the whole raised to 2. So this comes out to be 1 upon 1 by 2 the whole square, because this is sin kx upon x. So limit of sin kx upon x is equal to k. So value of k is half. So I will write half and the bracket whole square, therefore 1 by 2 the whole square. So this will be now L is equal to 1 upon 2 into 1 upon 4. So therefore this is 4 by 2. So hence the answer of this limit is 2. Therefore the limit x tan x upon 1 minus cos x when x tends to 0 is equal to 2. This is the final answer. Hope all of you understood this problem, and let us do some more sums. So next sum is this: evaluate the following limit. Limit x tends to 0 1 minus cos nx divided by 1 minus cos nx. Now in this problem, let L be the limit of this function. Limit x tends to 0, 1 minus cos nx divided by 1 minus cos mx. Again, we'll use the formula, that is 1 minus cos theta is equal to 2 sine square theta by 2. This is the half angle formula. Now, if you take theta is equal to nx, you will get the numerator expression. And if you take theta equal to mx, you will get the value for 1 minus cos mx. So, let us write this. 1 minus cos nx is equal to 2 sine square nx upon 2, while 1 minus cos mx is equal to 2 sine square mx upon 2. Hence, L is equal to now limit x tends to 0, 2 sine square nx upon 2 whole divided by 2 sine square mx upon 2. Now this 2 will get cancelled. Now we will have to divide the numerator and denominator by x square. Why? Because we have to get this version of this problem into the version of the formulas, that is the sin x upon x, limit sin x upon x is equal to 1, or limit sin kx upon x is equal to k. So L is equal to limit x tends to 0, sin square nx divided by 2 whole divided by x square, and sin square mx divided by 2 the whole divided by x square. So we have one expression in the numerator, another expression in the denominator. So let us take the limit of the expression in the numerator separately and limit of this expression in the denominator separately. In both cases, x tends to 0. So let's write this. So therefore, limit x tends to 0, sin square nx upon x whole divided by x square divided by limit x tends to 0, sin square mx divided by 2 whole divided by x square. So I will take the limit of this expression separately. So I will write this as limit x tends to 0, sin n by 2x divided by x the whole square, and limit x tends to 0, sin m by 2x divided by x the whole square. So now let us simplify this further. So L is equal to limit x tends to 0, sin n by 2x whole divided by x the whole square completely divided by limit x tends to 0, sin m by 2x whole divided by x the whole square. Hence, the answer of the numerator is n upon 2 the whole square. Here sin kx upon x, k is n by 2, therefore n by 2, and this is whole square, therefore n by 2 whole square divided by m by 2 the whole square. This comes to be n square by 4 completely divided by m square by 4. So this 4 cancels here, and therefore value of the limit is n square upon m square. Hence, the limit of this function 1 minus cos nx upon 1 minus cos mx is equal to n square upon m square. So here in this problem again we use those trigonometric limits formulas, that is the limit x tends to 0 sin kx upon x is equal to k. Same way we will do one more problem. So this is the other problem. In this problem first we will have to use cos c minus cos d formula. Now let us work out this. So cos c minus cos d is equal to 2 sin c plus d divided by 2 sin d minus c divided by 2. Therefore, cos ax minus cos bx is equal to 2 sin ax plus bx upon 2 into sin d minus c into sin d minus c divided by 2, that means bx minus ax divided by 2. So this will be 2 sin a plus b upon 2 into x into sin b minus a upon 2 into x. So this is a simplified version of the numerator. Now let's percent it of the given problem. So let L be the limit of the given function. Limit x tends to 0 cos ax minus cos bx upon cos cx minus 1. So now we know the value of the expression in the numerator. So this will be 2 sin a plus b upon 2 into x into sin b minus a upon 2 into x divided by, now this is cos cx minus 1. So I will take minus sign common. So this is 1 minus cos cx. So again this is 1 minus cos theta is 2 sin square theta by 2. So two into sin a plus b upon 2 into x into sin b minus a upon 2 into x divided by minus into 2 sin square cx upon 2. Now this 2 and this 2 will cancel, and this minus sign I will take it outside the limit. So this will be minus limit x tends to 0 sin a plus b upon 2 into x into sin b minus a upon 2 into x divided by sin c by 2 x the whole square. Now we will divide numerator and denominator by x square, so that we can use the formulas of trigonometric limits such as limit sin kx upon x is equal to k. So minus limit x tends to 0 sin a plus b upon 2 into x into sin b minus a upon 2 into x divided by x square Now we will take the limit of the function in the numerator separately and limit of the function in the denominator separately. In both cases, x approaches to 0. So therefore, minus limit x tends to 0 sin a plus b into x upon x, and the other expression is limit x tends to 0 sin b minus a upon 2 into x whole divided by x, and here it is sin a plus b upon 2 into x. So completely divided by limit x tends to 0 sin c by 2x completely divided by x the whole square. Now minus, what is the value of this limit? It is a plus b upon 2 into value of the another limit is b minus a upon 2 completely divided by c upon 2 the whole square. Therefore, now this 2 will cancel with this 4. We'll write it separately. So this is a plus b into b minus a divided by 4 completely divided by c square by 4 and this minus sign here. So therefore minus a plus b into b minus a divided by c square. So we cancel this 4 and this is a plus b into a minus b. I have used this minus sign here divided by c square. So this will be a square minus b square upon c square. So value of the limit of this given function is a square minus b square upon c square. Hope all of you understood this problem. And students, if you really want to improve your performance in JEE examination and the MSCT examination, I strongly recommend all of you to subscribe our channel. Thank you.